Hello everyone. So I thought I'd give you a quick update on the project and see, where things at, what I've been working on since. But I just wanted to start by saying the level of feedback I've got and everything from the first video is amazing. I started this project just as something fun to do for myself. I didn't think there'd be anybody who'd be interested in it, and to have so many people respond with such positive comments and stuff is fantastic. So I just want to say thank you to everyone who's shown an interest and is helping me with this project, because I didn't expect it. So it's always nice to know that that's something I've built other people find useful or interesting or whatever. So that's fantastic. So thank you for everyone who's commented and whatnot. So where are we? Okay, so in the last one we had the software showed you working. I've been working on my sort of local development environment. So as I mentioned in the other video, I'm starting a new job, and up until this point I've always used my works laptop as my personal computer, which is really bad. I know I really shouldn't, but it's meant every time I started a new job I've had to tear down that machine and reset up my development environment on a new machine, which never works, does it? You install all of your various IDEs and stuff, and then you spend 3 days figuring out why something doesn't work, and I didn't want to do that again. So I got myself a cheap little desktop PC. It's behind the TV cabinet, you can't see it, and I've been setting that up. So I've got a media server running on it, which is brilliant, so I can have all my pictures and whatever on it. But it also has Git installed. It's also got the Arduino CLI and all the various ESP tooling on there, and I can use an extension in VS Code, an SSH extension that essentially allows me to work on any machine as though I'm in the context of my development box. But the best thing about that is I don't need to have any dependencies on my remote machine. So the works laptop, as long as I've got VS Code, which I will have anyway because everybody uses that, I can access it. So that sort of solves that problem. So that's what I've been doing. I've been setting that up. But with that, one of the main problems there then is, where do I plug the ESP? Because if all of the CLI and all of the tooling is on my, my server essentially, I have to plug the ESP into the server, which is really inconvenient, and that's hidden away back there. So I've been working on a little solution to that. And I know this tools, I think it's called SOCAT or whatever, I don't know how you pronounce it, SOCAT. And that allows you to tunnel things, my understanding, my limited understanding of it. But I didn't know how to make that work, and my understanding of that meant I needed to install it on the client as well as the host. And the whole point of this is that I don't need to install anything on my works machine. It's purely just like a dumb terminal in an old school mainframe. So I've made a little web app. So I've got a little Node.js application that runs on the server, and I can use that in conjunction with VS Code to compile the project. I don't know if you can hear that, but my son's crying, so I'll be back in a minute. Sorry about that. He's nearly 3, and he dropped his dummy, so he started crying. But anyway, where was I? Yes. Okay, so my development environment. Yeah, so I can compile everything on there. I produce the various binaries for the bootloader and the partitions and stuff, and it merges all of them into a single binary. From that point, I need to get that into the ESP, and in an ideal world, I'd plug that into my works laptop. So what I've built is I let all the normal tooling get me to this point, and my Node app watches a folder that binary goes in, and uses WebSockets to push notifications out to a website, and that website will then load up that binary from the server and use Web Serial, which is a fantastic protocol, but it's only available in Chrome, which is stupid, to program the ESP. So long and short of it, I can basically plug my ESP into any computer that has access to my network, compile and build the application on my server, and then program the ESP in my laptop. Which is a fantastic sort of workflow, and it's making this so much quick and easy. And if I installed VS Code's web, they've got a normal application installed on your laptop, but they've also got like a web browser version. I could then, don't even need VS Code, and I could do it on my telly if I wanted to with a keyboard plugged in. But anyway, I forgot what I was talking about. So that's, oh yeah, that's the first problem I've been solving, you know, setting up my development environment. So now that's done, I'm actually working on the project. And a few people have mentioned, you know, could they get involved? And that's fantastic. You know, anybody who wants to get involved, please help. You know, it's just me doing it for fun. And they've been talking about testing. So I'm in the process of writing some documentation to tell you how to test it, how to build it yourself in its current limited form, so you can play around with it and do some testing. So it's not the simplest. What I will try and do is, with, you know, GitHub Actions on my GitHub account, essentially provide a binary that has everything compiled that you can then program to the ESP. I will also provide some scripts, probably a Bash script and a PowerShell script for, you know, Windows and Linux, that will do all of the commands for the Arduino CLI. So the idea is, all you have to do is download the zip file from the release in GitHub, and run one of those two scripts, depending on, you know, whether you're on Windows or Linux. Because for the Arduino CLI, you need to set it up a little bit. So you need to download definitions for the boards. You will then obviously need the command to program it. So the idea I'm having is that will take all of that away from you. You don't need to worry about that. You just run the script, plug your ESP in, run the script, and it will program it. But then you need a way of connecting the ESP to your PSP. And as my custom flex cables that I've talked about probably aren't production ready, I'd like to make some more changes to them. I wouldn't suggest anyone using them. They will be on the GitHub once I've set, you know, got all that neatened up, but I wouldn't suggest you use them. So you would also, I don't know if you can see it, need these, the FFC breakout boards. So you'll need two 10-pin and one 14-pin that essentially allow you to, and then you'll need the actual FFC cables, you know, just two cables, you know, with the male end on both ends that you can plug into the PSP and plug into them. And then you can use header pins like in normal, I don't know, Arduino projects to connect to the ESP. All of this will be documented. I'm just giving you, you know, a heads up as to what's happening. I'm saying a lot. So once you've got them, there's a few things to note with the ESP, that whilst they are cheaper than the Arduino, and they give me more options in terms of, you know, the web portal, they have less GPIO, well, less usable GPIO, I think. And if anyone knows any better, please correct me, because I am still learning with this. But there are there are a large number of pins that are input and output. You can use them whatever you want to do. There's a small number of pins that are input only, and they don't have pull up or pull down resistors, so you need to provide them yourselves. So they'll be being used for the various buttons that I'll be having, you know, to sync buttons and that sort of stuff. But there's some other pins that have reserved uses, and I've forgotten the name. There's a name for them, but they do things. You know, I think some of them are for like the boot, to put it in boot mode, you know, for when you're flashing and all those kind of things. You've got some other pins that are hooked up to the internal flash and stuff like that, so you can't mess about with them. And lastly, you've got some pins that output a PWM signal when the ESP is powered on. So if you don't know what a PWM is, pulse width modulation, it's basically a signal that goes high and low, and it's like a square wave, and it's the width of the on versus the width of the off and that sort of stuff. It's used a lot in, like, you know, in your car for various sensors and stuff. But the issue there is, I don't know if when it goes high and that going into the PSP would damage the PSP. I mean, they're both operating at 3.3 volts, I think. So would it just cancel out and everything will be happy? Or would it blow up the PSP? I don't know. So I will have to use some of those pins, but I will put like diodes on, so that at least when it goes high, that will block it getting to the PSP. And the worst case scenario is in the half a second, you know, it takes for the ESP to boot up, your PSP will think you're spamming the button, I guess. So I think overall it's still more beneficial to use the ESP, but it won't be quite as plug and play, I think, as the Arduino was. Unless obviously you build the PCBs that I'm designing, and that will have all of this stuff on, and then you just plug the PSP in, plug the ESP in and off you go. But if you're building it from scratch yourself, which you will be if you're testing this during my development process, yeah, there's that stuff to bear in mind. But all of this will be documented and things. So I think that's everything really. I can't think of anything else I was going to talk about. But the main takeaway is, you know, thanks for all the input. It's been fantastic. There's a fellow working on a really cool video doing a tutorial for my consolizer. So that was my first version of the project, where you take a PSP, take it apart and use the motherboard to make like a console you'd fit under your telly and use it like a normal video games console. You know, fantastic for damaged PSPs. And they're working on that video, so you know that's going to be awesome. You know, I never thought someone would do an install video for something I've built, so that's cool. Yeah, oh, the fridge had just turned off, it's gone very quiet. So that's it, yeah, so hopefully in the next video I can show you some more progress, show you more detail about how you could set up a development machine yourself so you can test this code and play with it. And yeah, I want to show you the web portal because that's really cool. So like I mentioned in the other one, how you can configure the GPIO pins that's been used, but I've extended that now to configure basic button mappings. I think I've just hard coded it for 4 buttons, but you can go in the web portal and change what PSP buttons those controller buttons control. So yeah, exciting stuff. So again, thank you everyone for your interest, and until next time.